Good evening, everybody. I am Dr. Dash from India. I am the ACS member since 2013. First of all, I give my cordial thanks to ACS chair and all ACS members for such tremendous event, ACS Spring 2023. Here, today I will discuss formula-based time economic mnemonics in chemical educations. So what is mnemonics? Mnemonic is a learning device through which we can remember anything in our brain long time. First of all, Formula 1, prediction of hybridization state of simple molecules of ions. In this case, the formula is power of the hybridization state equal to T S Lp minus 1, where T for total, S for sigma bond, Lp means lone pair of electrons. So this formula we use for 4 TSLP, and for greater than 4 TSLP, we split it in the following way. For 5 TSLP, 4 plus 1, and 6 TSLP, 4 plus 2, and 7 TSLP, 4 plus 3. For additional TSLP, we use D to get sp3d, sp3d2, and sp3d3 hybridization state. Next, power of the hybridization state of central atom or ions of organic compounds bearing positive or negative charge. In this case, the formula will be power of the hybridization state equal to Ts lnc minus 1. Here, lnc stands for localized negative charge. We can divide negative charge into two parts, localized and non-localized. That is delocalized negative charge. And by using localized negative charge, by using this formula, we can also predict power of the hybridization state. Next, power of the hybridization state of sp2 and sp3 for heterocyclic compounds. And in this case, the formula used is power of the hybridization state equal to Ts LLP minus 1. Here, LLP stands for localized lone pairs. That is in the same way, lone pair can be divided into two types, localized and delocalized. And by localized lone pair, this formula should be framed out. Next, bond order of diatomic species having total electrons 1 to 20 without using molecular orbital theory. So here we see there will be four formula 5, 6, 7, and 8. So yeah, and in every formula we just put the value of n. Here n stands for total number of electrons. Okay, for 1 to 2 we use the formula n by 2. For 2 to 6 we use the formula mod functioning for n by 2. For 6 to 14 we use the formula mod functioning 8 minus n by 2, and for 14 to 20 we use the formula mod functioning 20 minus n by 2. Next, the bond order of oxide-based acid radical. So this is the formula, valence of peripheral atom. So there is valence of oxygen atom plus charge on acid radical divided by total number of peripheral atoms. Okay. So this is the graphical representations of bond order with number of electrons. Now, we see the magnetic behavior of diatomic species also be predicted without MOT concept. So first of all, the species can be divided into three sets, set 1, set 2, set 3. So this is the three formula. For set 1, we use the formula mod functioning NAD minus total electrons. NAD means, here NAD stands for next digit. Okay, next electronic digit. So for 1 to 3, here minimum digit will be 1, so next digit will be 2. So for formula 11, here you see the mod functioning PED minus total electrons. PED stands for penultimate electron digit, that is digit before last digit. And for final set 3, we use the formula 20 minus total electrons to get an value. Okay, next, so spin multiplicity. So here the spin multiplicity can be calculated by using these three formula. Okay, n plus 1 minus n plus 1 plus n minus n plus 1. Next, so the aromatic and anti-aromatic behavior should also be predicted by using this formula. Here you see formula 16, formula 17. So formula 18 and 19 should also be used for the prediction of aromatic and anti-aromatic behavior of organic compounds bearing negative charge. And these formula 20 and 21 also be used for the prediction of aromatic behavior of heterocyclic compounds. Next, so these formula 22, 23, 24, and 25, 26, and 27 should also be used for calculation of chemical bonds in open chain and cyclic alkene systems. And these formula 28 to formula 35 should be used for the prediction of chemical bonds in alkyne and cycloalkyne systems. Here and here we see we just put the X and Y value. Here X stands for number of carbon atom and Y stands for number of hydrogen atoms to get the chemical bonds informations. Next, UPAC nomenclature of bicycle and spido compounds. So this is the formula 36, bicycle ABC alkane. Here A stands for maximum point, B stands for minimum point, and CB the CP minus 2, that is common point minus 2. And formula 37, this spido AB, here third digit is absent. A stands for minimum point and B stands for maximum point, excluding common points. And finally, we can write alkane on the basis of total number of points. And this formula 38 for substituent, bicycle, and spido compounds. So in result discussion sections, result and discussion based on 38 formula in organic and inorganic chemical reactions and are summarized in brief through the tables below. This is the tables. First table is for prediction of hybridization state. Second table is also for prediction of hybridization state for organic compounds bearing positive charge. Third for prediction of hybridization state for heterocyclic compounds. Then next, bond order of diatomic species without MOT. Then next, acid bond order for oxide-based acid radicals. The next, magnetic behavior of diatomic species without MOT. The next, spin multiplicity. And next, aromatic behavior of simple organic compounds. Next, aromatic behavior of organic compounds bearing negative charge. Then this is the aromatic behavior of heterocyclic compounds. And these are chemical bonds calculation of alkene and alkyne systems. Okay, and then this is the UPAC nomenclature of bicyclo and spido compounds. And it will be observed that this mnemonical formula should be very much too much helpful for designing computer-based learning activities, that is CVL activities. And two software has recently launched. One is hydrocarbon parsers and diatomic. Second one is diatomic bond order calculators, launched by mineralogy.com US, and these are indexed in New York City College for by using this innovative mnemonical formula. By using the hydrocarbon parser tools, we can easily predict the chemical bonds within a given hydrocarbon units, and from diatomic bond order calculator tool we can easily calculate the bond order values of diatomic species having 1 to 20 electrons. And these are the some references. These are some references. Okay, thanks to all of you for giving me the opportunity to share my views, and I think these mnemonics will be too much helpful in classroom lectures to remove phobia from students. Thanks once again, my ACS team. Thanks to all, and thanks to ACS chairpersons. Good day.